Every once in a while, a single year comes along that completely rewrites our relationship with the universe. Welcome to this explainer, where we're going to explore exactly why 2026 fundamentally changed our view of the cosmos. Now, this wasn't just a year of, quiet behind-the-scenes academic progress. No way. It was a spectacular, almost theatrical alignment of cutting-edge tech launches, massive international triumphs, and some seriously breathtaking natural phenomena that just lit up the sky. We're talking about awe-inspiring events that completely transformed modern astrophysics, spanning all the way from the absolute edge of the observable universe right down to the frost on the grass in our own backyards.
So why exactly did 2026 rewrite the textbooks? Well, simply put, it was a uniquely dense watershed year. We didn't just get one or two major space deployments. We got hit with an unprecedented, coordinated flood of high-tech hardware reaching orbit and venturing way beyond it. But honestly, what elevates this year from just a great scientific timeline to a truly historic cultural moment is that the high science happening billions of light years away was perfectly mirrored by incredible, naked-eye skywatching events right here on Earth. It was this rare, magical window where the professional astrophysicist monitoring deep space and the backyard stargazer standing on their porch were both looking up in absolute, unadulterated awe.
To really wrap our heads around this incredible year, here's our roadmap. We'll start with 2026 as the astrophysics watershed, then move into unlocking deep space secrets, explore our dynamic solar system, look at naked-eye astronomical wonders, and finally wrap up with the new cosmic perspective.
Okay, let's dive right into Section 1, Unlocking Deep Space Secrets, Reaching the Edges of the Observable Universe.
So, late 2026 into 2027 marked the deployment and prime operational phase of some absolute heavy hitters in astronomy. I'm talking about machines explicitly designed to peer into the universe's oldest, darkest mysteries. For decades, the beloved Hubble Space Telescope has been our gold standard, right? But NASA's Nancy Grace Roman Space Telescope, it changes the game entirely. Its wide-field instrument has a field of view 100 times greater than Hubble's infrared instrument. Imagine trying to take in a massive, beautiful mural by looking through a tiny drinking straw. That's basically what we were doing before. The Roman Space Telescope essentially swaps out that tiny straw for a giant picture window. And guys, we desperately needed that window because dark energy makes up roughly 68% of our universe. To even begin comprehending a force that massive, we absolutely need the unprecedented scale that Roman provides to map dark energy and do these vast censuses of distant exoplanets.
Now, what's really cool here is looking at how these diverse, collaborative, international missions rapidly deployed to solve distinct astrophysical mysteries. This was definitely not just a NASA show. You've got the European Space Agency's Plato mission aiming its multi-telescope array at finding Earth-like exoplanets right in the habitable zones of their stars. Meanwhile, the SMILE mission, which is this awesome joint effort between Europe and China, launched in May to map exactly how solar winds interact with Earth's magnetic shield. That gives us incredibly crucial data on space weather. And then there's China's own 2-meter optical space telescope, Suntian, positioning itself to co-orbit with the Tiangong space station to help out in the global effort of mapping dark energy. It was just a beautifully united, worldwide push into the great unknown.
But hey, the giant observatories weren't the only ones making waves. The year actually kicked off with a rapid-fire succession of smaller, highly targeted astrophysics missions. Right on January 11th, a single launch delivered Pandora, which is a small telescope studying exoplanet atmospheres, right alongside specialized CubeSats like SPARCS and Black Cat. And this is where the science gets so incredibly specific and fascinating. SPARCS monitors ultraviolet flares from M-dwarf stars. Now, those are super common, incredibly volatile red dwarf stars that constantly lash their surrounding planets with intense radiation. Meanwhile, Black Cat is out there observing X-ray transients, which are basically these sudden, violent flashes of energy, usually bursting from black holes or neutron stars feeding on matter. These small but mighty satellites proved, for sure, that you don't always need a multi-billion-dollar budget to capture some of the most extreme physics in the cosmos.
Moving right along to Section 2, our dynamic solar system, zooming into our cosmic neighborhood.
So the crucial number for this next part is 6. In mid-2026, NASA geared up for the SunRISE mission. Now, SunRISE isn't your traditional satellite. It's an interferometer, which sounds complicated, but it just means it takes 6 distinct, individual CubeSats flying in formation and combines their separate signals to act like one giant, virtual radio telescope out in space. By doing this, scientists can track and study the origins of massive solar radio bursts. And understanding these bursts is absolutely vital for us, because extreme solar weather can severely disrupt Earth's communication networks and our power grids. By combining 6 tiny boxes into one massive sensory net, Sunrise basically delivered a masterclass in distributed space engineering to help protect our modern way of life.
Speaking of engineering masterclasses, the European Space Agency's Proba 3 mission gave the scientific community an absolute roller coaster ride. In February 2026, the mission experienced a terrifying anomaly, and ground control completely lost contact with one of the spacecraft. It looked like a total, irrecoverable disaster. But cue a massive wave of relief, contact was successfully re-established in March. Overcoming that near-death experience allowed the 2 spacecraft to actually do what they were built for. Get this, they had to fly in precise formation, literally millimeter perfect, while hurtling through the harsh void of space at thousands of miles an hour. One satellite precisely cast its shadow onto the other, creating a giant artificial solar eclipse, or coronagraph, so we could safely study the sun's elusive, blazing outer atmosphere. Unbelievable stuff.
And our understanding of our immediate neighborhood expanded in other profound ways too. July 2026 was a total blockbuster month for interplanetary intercepts. Japan's seasoned Hayabusa 2 probe executed this super-close, high-speed flyby of the asteroid Torifun. Simultaneously, China's Tianwen 2 mission arrived at a really intriguing target, Kamo Olowa. This is a mysterious asteroid that actually acts as a quasi-moon. Yeah, you heard that right. Earth has a stalker rock awkwardly co-orbiting the sun alongside us, and we finally sent a probe out to check it out. Missions like these are absolutely critical. Not only do they help us piece together the chemical origins of the early solar system, but they directly advance our planetary defense capabilities, ensuring we know exactly how to intercept near-Earth objects way before they ever become a threat to us.
To cap off this solar system zoom-in, we absolutely have to celebrate humanity itself returning to the deep dark. 2026 witnessed the historic triumph of the Artemis II lunar mission. The courageous crew of Artemis II didn't just fly by the moon, they pushed the boundaries further than ever before, completely eclipsing the all-time record for the farthest human spaceflight in history. When their capsule splashed down perfectly in April 2026, the collective sigh of relief was felt globally. They didn't just complete a pristine test flight, they fundamentally and permanently set the stage for humanity's sustained, long-term return to the lunar surface.
All right, let's bring it closer to home with Section 3, Naked Eye Astronomical Wonders, Grounding the Science on Earth.
We've talked about the absolute edge of the universe, and we've talked about sophisticated deep space probes. Now let's bring the science right into your backyard. To truly understand the magic of 2026, we first need to define a crucial term, opposition. This is a celestial alignment where a planet is fully illuminated by the sun from our specific perspective here on Earth, meaning the Earth is sandwiched directly between the sun and that planet. This geometrical perfection makes the planet appear at its absolute brightest and keeps it visible all night long. Well, 2026 gave us spectacular oppositions for our solar system's 2 gas giants. Jupiter reached opposition right at the start of the year on January 10th, totally dominating the winter night sky, while Saturn followed up with its own brilliant opposition on October 4th, showing off its rings with stunning clarity to anyone with even just a basic consumer telescope.
But I have to say, the absolute crown jewel of the 2026 calendar happened in mid-August. On August 12th, a stunning daytime total solar eclipse crossed Greenland, Iceland, and northern Spain, marking mainland Europe's first total solar eclipse since 1999. Now remember, a solar eclipse can only happen during a new moon phase, and a new moon guarantees that the subsequent nighttime sky is going to be perfectly dark and entirely moonless. Which was perfect because the very next morning, the famous Perseid meteor shower hit its absolute peak, delivering 60 to 120 blazing meteors every single hour against a perfectly pitch-black canvas.
Because of the way the orbital paths and the timing flawlessly aligned, eclipse chasers who positioned themselves in Spain hit the ultimate astronomical jackpot. They experienced a breathtaking, literally once-in-a-lifetime double feature. They watched the sun disappear into a total solar eclipse right at sunset, the sky turning this deep twilight purple, and then they just stayed awake to watch the blazing Perseid meteor shower rain down shooting stars just a few hours later. It is pretty safe to say that thousands of astronomers and tourists in Spain happily didn't sleep for a full 48 hours, observing 2 of nature's greatest, most awe-inspiring celestial spectacles on the exact same day, in the exact same place. That is an extraordinarily rare alignment that deeply moved everyone who was lucky enough to witness it.
Which brings us to our final stop, Section 4, the new cosmic perspective, connecting high science to the human experience.
All of these events we've talked about,
The massive space telescopes, the daring solar probes, the beautiful backyard eclipses, they all weave together into a unified story. As the scientific consensus notes, these aren't just isolated events. Together, they represent a leap in our ability to predict solar weather, understand dark energy, and look up at the night sky with new wonder. And honestly, that is exactly the ultimate takeaway here. 2026 gave us the incredible technological tools to map the invisible dark energy shaping our reality. It gave us the interferometers to predict the violent solar flares that threaten our electrical grids, and it gave us those naked-eye eclipses that humbly remind us of the sheer, majestic clockwork of the solar system we live in. We walked away with both invaluable hard data and profound, perspective-shifting inspiration.
So with this unprecedented flood of cosmic data now firmly in our hands, from the Roman Space Telescope mapping the dark cosmos all the way to Artemis astronauts breaking deep space records, how will 2026 ultimately change humanity's perception of our true place in the universe? Will all this vastness make us feel endlessly smaller? Or will the very fact that we can even comprehend such scale make us realize how truly significant we actually are? Just think about that the next time you step outside on a clear, dark night. Look up at those stars, remember the incredible leaps we've made, and just let the wonder take over. Thanks so much for joining me on this explainer. Keep your eyes on the skies.